Hello, everyone. In this presentation, I want to talk about annual worth analysis and its capability to compare different alternatives. So if you recall, in Chapter 5, we learned how to use present worth analysis to compare different alternatives. So all we did was to calculate present worth or capitalized cost of a project or of an alternate of different alternatives, and just compare those final numbers together and choose the best alternative. But in this chapter, we are going to talk about annual worth analysis. Really, all you need to do in this chapter is to calculate the equivalent annual worth of different alternatives and compare the final numbers. So really, we are not learning anything new again in this chapter. Why? Because you will be comparing just two different numbers where these numbers are the annual worth of different alternatives. So again, as you can see, you have learned this concept of annual worth analysis and how to convert your cash flows to equal equivalent annual worth in chapters 2 and 3. So in this chapter, we just learned how to compare different alternatives. But the nature of the work, it's something that you have done before. It's nothing new. So I just want to start with a very easy example that we had in previous chapter. In previous chapter, we said when you want to compare two alternatives, if the projects have different lifetimes, for example, we calculated the LCM of the projects, and for example, LCM of projects two and a project with a lifetime of 2 and a project with a lifetime of 6 was equal to 6. So we repeated the shorter project 3 times until we hit 6 years or 6 period. And then we calculated present work. But don't you agree that that was kind of like additional work that we did? It will be very nice if, for example, if I have a project with 2 years of lifetime and another project with a lifetime of 6 years, I can directly calculate the annual worth of this project and compare it with the annual worth of this project. So as you can see, really, you don't need to do any extra work. You don't need to be worried about inequality of the lifetimes. For example, let's say if you have also two projects with the if you have two alternatives with the lives of, let's say, 11 and 9, what is the LCM? LCM is going to be 99. So it means that you have to repeat this project until you hit 99, and you have to repeat this project several times, or this alternative several times, until you hit 99. And we said that, for example, for numbers like 99 or like large numbers generally, in order to calculate the capitalized cost, we had the equation of A over I. So the question that I have for you is that what's wrong if I want to use A directly instead of dividing that by I? And it's exactly the topic of our discussion, that you don't even need to come up with A over I. And most of the time, you can just calculate just the annual worth resulted from this project and choose the one that gives you better annual worth. So again, there is nothing new in this chapter. You just need to calculate the annual worth of a project. Of each project, and just compare those numbers together. So let's say if you start with a cash flow diagram that, for example, you invest $50 million in a big project, and this project will give you 1, 2, 3, all the way up to, for example, infinity, or to a large number of years. It will give you $2 million of profit per year if you spend 50 million or invest $50 million. So And of course, this project can have a salvage value that we really do not care about the salvage value if it is in long future, far future, and we have proved that. We have talked about it in previous chapter. So if I want to calculate the annual worth of this alternative, it will be equal to, you already have 2 as your annual worth, which is $2 million given per year. All you need to do is to convert this present worth to A. So do you agree that if in the previous chapter we said capitalized cost is equal to A over I, do you agree with me that A is equal to I times capitalized cost? Okay, and capitalized cost is really your present worth. So if I want to convert this $50 million to annual worth, it will be, because it's in negative direction, it will be negative 50, and then multiply it. It will be your capitalized cost or present worth. You just need to multiply it by I, and let's say I is equal to 10%. So in this way, I have calculated the annual worth of this project, which is, for example, negative $3 million. So let's say I have another alternative, that this alternative, for example, has an initial investment of $10 million. And this project, instead of having the lifetime of infinity, have a limited lifetime of 4 years. So if during each year it gives you, for example, $5 million benefits, and also you know that after year 4 you will have a salvage value equal to $1 million over here. So as you can see, if I want to compare alternative, let's call them A with alternative B, these projects have the different lifetimes. If I were in previous chapter, I had to calculate the LCM, and I had to assume that both projects have lifetime of infinity, because LCM of 4 and infinity will be infinity. But the good news is that in this chapter, I don't care about this lifetime, because I can directly convert them to annual worth. So let's say if I want to calculate the annual worth of the second project, I have this $10 million that I need to convert it to A for that given period of 4 years. So I have 10, I want to find A for that given P for interest rate of 10% and period of 4 years. I also have $5 million, which is already given as annual worth, plus you have $1 salvage value, which is the future worth for this period. So you want to find 1 times, you want to find A for this given F, 10% and 4. So if you do the math, I think this answer will be 2.06 if I'm not making mistake. So you can just do the calculation to confirm that. So this one has annual worth of negative, this one has the annual worth of positive. So obviously in this case, which one will be selected? You will select alternative B is selected. So that's the advantage of having annual worth analysis technique, that I don't need to be worried about the equality or inequality of the lifetime of the projects. Okay, so that's just one of the basic concepts that we learn in chapter 6, which is about annual worth analysis. Another concept that we have in that has been discussed in this chapter is the concept of capital recovery. So let's just have one example of capital recovery. For example, you purchase a car. For $20,000. You purchase a car for $20K. And you want to work in Uber with this car, okay? And you know that you will be selling this car for $5,000 after 5 years. For $5,000 after 5 years. Okay, assume interest rate is equal to 10% per year. So you are gonna make money by working in Uber using this machine. So the question that I have for you is that how much should you earn per year? How much should you earn per year to break even at the end of end of year 5? So you are gonna make some money by working at Uber, but the question is that how much you have to make per year to break even, or how much money should you make per year to recover your investments? How much is the same as saying how much money should you make to recover your investments? Okay. How much money should you pay to recover your investments? Okay. So let's just draw the cash flow diagram for this example. You have paid $20,000 at time equal to 0. I will just drop 3 zeros to make the life easier. And at the end of year 5, you know that you are gonna sell this car for $5,000. But I just dropped 3 zeros. So the question is that how much money you should make per year to justify this investment, or to break even, to reach a break-even point, or to recover your initial initial investment. So to answer this, you need to just write your cash flow diagram, and when you hit the break-even point, or the point that you can recover your initial investment, is the place that your overall cash flow, your total cash flow, is going to be equal to 0. So for example, over here, I'm looking for the value of A, how much money I have to make per year to recover my initial investment, is plus, you have 5, and that's, you want to find A for that given F, because it is like a future worth for this period of 5 years. And I have a $20,000, which is like a present worth for this problem, and I want to convert that to A. So it should be minus 20. You want to find A for this given P, 10%, and set is equal to 0. So as you can see, you do have the values of these factors. For example, A given P, 10%, and 5 is 0.2638. And this guy, A given F, is 0.1638. So as you can see, the only thing which is missing is the value of A. And A, if I do the calculation, it will be 4.457. So this A is what we call capital recovery. It's called capital recovery, which we show it with CR. Capital recovery is the amount of money that you have to make per year to justify your initial investment, or simply is what you can do, or on the amount that you have to make to recover your initial investment. And that's why we call it capital recovery. That's simply we show it with CR. If I want to come up with something very general for capital recovery, which is the same as your A. That's why we are talking about it in annual worth analysis chapter, where CR is equal to P times A over P I% and N minus salvage value A given F I% and N. That's really just a generalization of what you have over there. So as you can see, A is equal to 5 minus 20. Or I mean, in this case, you need to find the amount that you are making to recover your initial investment. So with this presentation, I will take a pause and because we're going to solve some examples. So I will solve the rest of the examples through a separate file.